algebra expression, theory optimizer will not use the select from where. Instead, they will use relational algebra expression. Okay, much easier. Okay. Select. We will start from the select. So, when you select the table, these are the examples. So you can select the employee using the social security number, and also, or sometimes the number is a 5. Any difference between them, OP1 and OP2? OP1 is using primary key. Okay, one data will be selected. While on the other hand, OP2 is range query. Okay, all department whose number is bigger than 5. Even this one is different from the OP3, right? Because it's a range. In this case, we need to compare this one first. The OP1 and OP3, even though they are accessing the same table employee, but this one is the primary key, only one data will be returned. On the other hand, this one, a group of data will be returned. So, obviously, intuitively, in this case, you'd better use primary key, B plus 3 index if you have. Okay? What about this one? At this time, you'd better use clustering index if you have. So this one is called clustering index, index for group data. What about this one? OP2 and OP3. Now OP2 and OP3. This one and this. Okay. Both of them are accessing employee, but in this case, this is the range query. So bigger than all the data. If you have B plus 3 for this one salary, you can get the benefit of sibling, right? You don't have to be up and down. Instead, you can go to next one. So each query are different. Even though you select this one, there are a bunch of different ways. So we will see each and every case of selection operation. First, linear search. Linear search, obviously, from top to bottom, read all the blocks. Binary search is good for what? In case tables are ordered. Okay? Is it obvious? Why not? Most of the commercial DBMS system, they do not use ordered data file, ordered table. Why? Why they do not make them ordered? Insert, delete, whenever you insert and delete, update, you need to sort the data. Okay, entire table. Think about you have 1 million of data in one table. Whenever you insert, update, delete, should be sorted. Huge overload. Instead, leave as it is data. Instead, you can manage indexing. Okay, you can create a B plus 3 or B3 index separate. So, manipulating 3, the B plus 3, B3 index is much faster than the entire data. Okay, but still you can use the binary search in case tables are ordered by certain column. Okay. If you have a primary index or a hash key index, that is the one way to use. At that time, mostly the data file table are not sorted, but you have primary key. It can be primary index, single level index, right? Single level index, so you can access the data. Sometimes this one is access only one data. It called condition in where? What if you have inequality like that? That is range query. Why they are separate? Depending on the range. Sometimes if the range is very narrow, you can use index. If this range is wide, cover 80% of your data, which one is better, indexing or linear search? Still index? No. It's a linear search is there. So you need to separate such a range query from the equality. Okay? If you have the clustering index like the DN, you can consider DN. Secondary key is the most popular one. If you have the such a B plus 3 or B3 index, you can use this one, then access the data. Usually, the data files are not sorted, randomly inserted for B3 index, B plus 3 index. That is a secondary index. Also, this one can support inequality, right? B plus 3 has the sibling pointer. Conjunctive selection is in case of this kind of thing. So DN equal 5. This is the, let me use the clustering. Salary, there is no index, linear search. Sex is a female. You can have the index, sometimes not. So which one is the best one? So in conjunctive, unless you have the conjunctive index, combine the index, you need to select one of these conditions, which is the fastest one, low cost. That is the conjunctive. Conjunctive selection using, in case you have composite index, so combination between sex and the salary, you can use that one, right? Conjunctive selection by intersection of the record pointer, you can separate always such a case. So how many different ways in this case? Even 9 different ways to access the table. Is that all? No, there might be different ways depending on the indexing type. So this is a general cases. So next, actually I forgot. In this 1,000, should be more than that. I forgot the one more condition, that is the join. Okay, let's little bit go back to this one. At this time, we consider way over accessing the data, right? Table. Also order of the table. The next one is how to combine. That is a join. There are different ways of join. Join this one, join this one. So we will see that here, nested loop join first. What is a nested loop? No way? You never use a nested loop?
No, just nested loop. Why?
Why? Loop inside the loop. That is a nested loop. It's the natural way of the loop. For example, if you have the for loop I equal to 1 to 10, and for loop j equal to 1 to 10, okay, then the k is I times j plus k. It's a nested loop. For each I, for each j, you can multiply and add up, right? It's the same thing. Nested loop is when you join two tables, employee and department. For each record of the left-hand side, check all tuples in right-hand side. Then check what? Check what? Join condition. When you join employee department, you have D NO equal to D number. This is a joint condition. Whether joint condition is satisfied. If yes, return. Otherwise, don't forget about that. Next. Next. All and every cases. That is called nested loop join. Okay? Then single loop join. What is a single loop? It's a single loop, right? Why can it be the single loop join? Employee and department. In case you have index of department. Okay? This is the inner table. This is the outer table. This is the driving table. This is the driven table. In case you have index for driven table, you don't have to visit all department. Instead, whether D NO is equal to 1. Find 1. You don't have to move. Next, 2. You have 3. 10, 10. 2, 2. Using 1. Index or driven table, outer table. How many loops? Only one loop. Single loop join. Okay? So nested loop join is a brute force way. Because you do not have any index, you do not have any benefit. On the other hand, single loop join, in case you have index for outer table, what driven table, you can get the benefit of that. Okay? Only one time loop. Because of that, which one is better? When you have the 1 million of employee and the 10 department. If you are using the nested loop join, it doesn't matter. DPT first or employee. Okay? Anyway, it takes the 1 million times of the 10 million times. But single loop join is a different story. In case you have the single loop join, if you have the employee with the clustering key, you can access department first. 1, then apply the clustering index. How many times? Only 10 times. Why? If you put the employee as the driving table, how many times? 1 million times. It's a huge difference in case of single loop join. Sort merge. Sort merge join means sort and merge. Probably you already know such a sorting mechanism. So let's say we have join employee DPT changing D NO equal to D number. So we have employee. So D NO. We have department number. To join nested loop join with combination of all of them, 2 loops. Single loop join will use the benefit of index in driven table. In case you do not have any the index, so we need to use nested loop join. Still, nested loop join is too expensive, but I have very good sorting algorithm. Okay? How many different sorting algorithms do you know? You probably learn in algorithm course, right? If you are taking algorithm course, it will be final exam. So, sort the data by DM column. So 1, 1, 2, 2, 2, 2, 1, so 2, 2, 2, 10. Sort the data 1, 2, 1. Or it's a primary. So 1, 2, 10. Then from sort, we did the sorting. And merge from top to bottom. Compare. Yes, yes, yes. If different, go to next. Yes, yes, yes. If different, go to next. That's it. It's a sort and merge. sometimes sort and merge is very, very effective, especially in batch job or data warehousing system, not online transaction. Not unlike the banking system. Banking system requires faster response time, but this one is working very well. That is the sort merge. Hash join. What is a hash function? Similar to indexing?
Yeah, that's different.
How to do? How? Hash. I think that we discussed about what is a hash before. Hash function is the function that can simplify very complicated data as a simpler one. What is the typical example of that? Modular. Modular, whatever the number you have, so modular by 10, you will have 1 of 10, right? 0 to 9. Similarly, when you have the data, the driving table, reading table is employee and EPT. In the memory, you will create the hash bucket. How many? Let's say 3. Then 1 divided by 3, 1. This one goes to here. This one goes to here. This one goes to here. 2 goes to here. Go to here. 10 goes to here. So let's say this is A, B, C, D, E, F, G, A, B, C, G is here, D, E is here. Okay? This is in the memory. Then, for this one, driven table, you can do the same thing for DNO 1, 2, 10. 1 is divided by 3, so goes to here. Then check each value, whether they are matched. 1, 1, 1 match it, so we 10 may not. Okay? But 2 match it, return. And 10, not. This one is match. This is hash join. Hash join is faster than expect. So many times it's all ignored from the user, database administrator, by the database developer. But sometimes hash without creating the index, this one is very fast. So hash join, that is called the hash join. How many different ways? Even 4 different ways of join. Depending on the DBMS standard, there are different types of the join mechanism. These are the typical examples. So there are many. So even for selection, 9 different ways. For join, 4 different ways. Okay? So for cost space optimizer, there are a bunch of different cases. We need to decide the cost of each way. Okay? We will skip the hash join function. There are issues actually for hash join. So for example, partitioning place and joining place, how to partition the data, what is the optimal size of the hash key, something like that. And sometimes you need to join. Okay, so next class we will start with the heuristic rule. Okay, before we learn the cost function, we will learn the heuristic rule that can minimize the cases. Okay. Also, next class on Thursday, I'm going to invite the Professor Arif. Actually, he will present in the Engineering 400. I think the most of you guys already took that test, that Engineering 400, but he is the speaker in Engineering 400, but his expertise on database. So I personally invite him to present. It will not be formal presentation, instead it's a very light talk. So you can even ask the question, what's going on in the database area, if you are curious. So please do not miss such opportunity next class. But he will join in the middle of class. So first, we are going to finish the heuristic part and the part of the cost function. Then he will join around 2:50 to give us the light talk about the database. Okay? Any question? So you don't have to submit the last homework. There's no question. I forgot to ask you to get the question about the normalization, but you can study by yourself with the key. It's already posted on the class. Thank you.